Okay, here's my science reflection. Sorry, I'm in a really creepy closet. I'm at work right now. So the first question says, please explain what a misconception is as it relates to science instruction. So a misconception is like a belief that students have about something based on their experiences from like their home life, their environment, like what they grew up knowing or what they grew up being told. And sometimes they don't hold like any scientific proof. Like they're just basing it off of what they've seen. And so having a classroom full of different kids that come from different backgrounds are all going to have different kinds of misconceptions. And so it's really hard to teach a lesson when your class may all believe something different about one thing. And so two common examples of this would be that objects float because they're lighter than water and objects sink because they're heavier than water. And I actually did a lesson on this in my practicum class. We asked the kids if they thought a pumpkin would float or sink, and like 90% of the class was like, yeah, it's gonna sink because like in their mind the pumpkin is heavier than the water. Then there was one kid that explained to the class like that he thought it was gonna float. And so they had this misconception about buoyancy and air and stuff, and we addressed that by testing it. And we had a big bucket of water and put a pumpkin in there. And I would leverage misconceptions in my classroom by using them as teaching opportunities. So we use their misconceptions to either prove them right or prove them wrong. Not wrong, but like debunk their misconception. Because if you prove it to them, they're going to be like, oh. But if you just tell them, well, it's going to float, but you have no like proof or ways of showing them that, then it's harder. So I would leverage that by like making it hands-on learning. And I also would leverage it by making it more of like a student-led thing, because in that lesson that I did, one of the students was like, he's above grade level and he's very knowledgeable. Like I was like shocked what he was saying, but I was like, could you explain your thinking on that? And he explained to the class what he thought about it in his own words, and it was almost easier for them to understand it coming from their peers. So kind of opening it up like class discussion and allowing students to teach each other would be another way. By having two different ideas about what might happen or several different ideas of what might happen, with misconceptions, it like I said, opens up to class discussions, and you can talk about like how, what, why. And testing it would be super important. And in my future classroom, like I would want to do hands-on learning and experiments, because that's like how I learn best and how most students would learn best, is by seeing it. And then that was kind of 1 and 2. The third one, explain terms of progression of standards. So progression of standards is like if you're in a kindergarten classroom and you have one standard, which I found one that says, this is the standard: some events on Earth occur quickly and others can occur slowly. So that's the standard for kindergarten, very simple. And as you move up grade levels, that same standard holds true, but then it just adds a little bit more detail and a little bit more, detail. So then the 3 through 5 standard of that same one says certain features on Earth can be used to order events that have occurred in the landscape. So it's the same concept, it's just you're building on it even more. And then the 6 to 8 one is rock strata and the fossil record can be used as evidence to organize the relative occurrence of major historical events in Earth's history. So like obviously that from that kindergarten one to that one is like, whoa, major difference. But it builds upon the first one more. This is Jordan. She's just doing her work stuff and I'm sitting in the closet. So the standard builds upon the last one, so that's like progression of standards. It just continues to build upon and grow. And now I feel weird talking because Jordan's in the background. Okay.
I'm trying to count the money.
Okay, the fourth one, what would you do if you're a fifth grade teacher and you had to teach this lesson? What would students bring into your classroom and stuff? So the standard states make observations and measurements to identify materials based on their properties. So students will come to my classroom with experience being able to conduct investigations with controls and variables. So that's one thing that they'll have and need to have. Say bye, Jordan. Yeah, so they'll come in with experience conducting investigations with controls and variables. And we'd build upon that, because making observations and measurements, you'd have to do experiments and stuff like that. So just building upon that, making measurements, and it also notes that at this grade level, mass and weight are not distinguished. So that's something that would come after this lesson and that we would maybe touch on, but we wouldn't go into detail about. So that's something they'd learn after. The 5E learning cycle. So engage is like grabbing their attention, their curiosity, and sparking their prior knowledge, making connections based on what they've previously known and what they're going to learn, and just getting them to be like, whoa, this is going to be cool. I want to see what we're going to do, and I want to try this. An example would be like a video, an open-ended question related to the topic. And then explore is actually taking that curiosity and like putting it to work and allowing them to fail, allowing them to explore different outcomes and solutions. And the teacher kind of just facilitates that part. They're not telling them, don't do this, don't do that. So an example like we did in class was like building a house to withstand certain kinds of weather. We don't tell them how to build it. They just have certain requirements and restrictions, and we want them to fail, and we want them to try different ways of doing it. Explain is what they did. Explain what they did, why they did it, and like what worked, what didn't, and the science behind it. Make connections between their prior knowledge and what is like true. This is I think is kind of the portion where you kind of debunk misconceptions, like, oh, you thought this would work in your experiment, but it didn't because of this. So it kind of analyze what they did, and the teacher explains, and this can be through like oral presentation, a video. Elaborate is like revisiting that previous situation or activity and building upon what they previously did with the new knowledge that they just gained from the explain phase. So the new concepts and like the actual science behind it, then they're like, oh, that makes way more sense. Let's try it this way. So yeah, the example would be like going back to that previous one and like using their new knowledge and concepts. Then evaluate would be evaluating the student's progress and understanding through multiple different forms of assessment. Like you want to see that they grew throughout the authentic experiment. Like you want to see them make changes and design new things and stuff. So they can like summarize their learning. Okay, the engineering design process. Engineering design process is, the first one is ask, second one research, imagine, plan, create, test, and improve. So I work at the Discovery Center as well, and this always comes back in my mind what we did. We had the students use this engineering design process and build a windmill, and I think we did that in class actually too. But first we asked them, like, we identified constraints that they had. So like there's the constraints were the materials and their money. They had money that they could spend at the hardware store. So like that was the asking and identifying constraints. Researching the problem, not necessarily a problem, but they had to like research what like entails a windmill, like what's it made of, what are the purposes of it and stuff. And then they had to like imagine how they were going to build one, and so they like drew. That also kind of goes into plan, imagine and plan. They had to like imagine how they were going to do it and then plan that out, and they would draw like sketching different ways that they could do it with different materials, and then they'd actually create it. They'd go to the hardware store, buy their materials, and create it as a group, and then we'd put it in front of a fan and we would test it and they had to be able to spin. That was one of the constraints, or like one of the things needed that they needed to do. So see if it could spin or if it like blew over and stuff. So we would test it. Then we go like back to the drawing board basically and be like, okay, what worked, what didn't, why did it fall over, why didn't it spin? And so then they would revisit that, and then they would improve their design and like get different material or like avoid a certain kind of material, stuff like that. I think the deepest learning comes from when they improve it, because like we've said in class, like most experiments stop when they just test it and then they just like talk about, well, this is why it works, but they're never able to like go back and physically like improve it themselves. And I think that's where they connect prior knowledge, what they've learned, and then like actually do it. So yeah. What's been most helpful? I think our big group assignment was lesson was super helpful for me, not only like creating one, but also like seeing everyone else's. It like gives me so many ideas and ways to improve or what not to do and what to do, and see what worked for other groups and what worked for our group. That one was really great. I didn't really think there was an assignment that was least helpful. I all felt productive and meaningful to me. So yeah. That's pretty much it. Good. Thank you.